Well, good morning, everybody. Today, I want to demonstrate an instrument that I received here last week. It's a Tektronix 571 curve tracer. And I've been looking for curve tracers on and off over the years. Uh, some of them were, I think, priced a little more than what they should have, and a lot of them are, essentially repurposed oscilloscopes and take up a lot of disk space, and they're heavy and cumbersome to operate, so forth. But I came across this one. I've seen these on and off over the years, and I just didn't think I would need one at the time, so I just kind of would let it go. But I came across this one, I looked at it, and I went, "Oh man, this thing's actually in pretty nice condition. It's priced reasonably," so I decided to go for it. And so far, I've run it through its paces, and I'm pretty pleased with it. So in this video, I'm going to demonstrate how to use this instrument and kind of go over its basic functionality. So the unit in here, it features, of course, a 9-inch CRT. The test fixture over here has a number of sockets. Some are designed to be used with certain K-style devices. Here you use the 220 style devices. In this socket, we got a 292 socket over here. I have a 2 and 222 transistor installed. This here is for 2-3 style cases. And then we have a couple of other sockets that are kind of just general purpose. Over here we have a little fixture that's plugged into what are essentially 3 banana jacks behind here. And it features a couple of smaller transistor sockets for installing transistors that don't or can't be easily used with any of the available ones here. We got menu buttons down here that you can navigate the menus with. We have a start and stop button here for running your tests. A menu button here, store button for storing parameters. We got a cursor button to move that's used to make measurements, and a copy button that will send whatever you have on the screen to a printer. There's a Tektronix printer port on the back. It's one of the larger ones. It's the same one that you see on the back of the printer, so I got a cable cubbing. I should have it here next week, and otherwise I'd demonstrate that, but we'll just have to do what we can here. So before we get going here, I thought I'd just show you the back. Of course, we've got the power, this full-size Tektronix printer port. We have a switch here that's used for testing the unit. Right now it's set into a normal mode. And then there's a set of test routines in the ROM that you can run to test the unit if you are suspicious that it's not working correctly. And then we have, of course, the intensity control for the CRT. Alrighty, well, enough yakking. Let's power this thing on and give you a demonstration. Green CRT goodness. Okay, this is how it comes up when you first power it on. It's just got a standard set of defaults, or instrument presets. And you use the keys here to move this cursor up and down and change the values for the function that you want to conduct. Right now it's set for a single acquisition. The type of device we're testing here, which is set defaults at an NPN transistor. The voltage, the collector voltage you're going to apply to the device, it's currently set for 5 volts. The collector current is currently set for, 10 milliamps. Here is where you set the current to drive the base of the transistor, and right now it's set for 10 microamps. You go down here, and this is the amount of steps that will be used. It will start off, right now it's set for 10, so it'll start at 10 microamps, and then go to 20 microamps, and 30 microamps, and so on and so on and so on. Here we have the resistive load that that's excuse me, that's applied to the emitter. And right now it's set for 0.25 ohms. You can either set it for 10, 100, 1K, or 10K. And down here is the amount of power, overall power we're going to apply to this device. Right now it's set for 100 milliwatts. And you can go to 500 milliwatts, 2 watts, 10 watts, 50 watts, and even as high as 100 watts. Then down here we can retrieve one of 12 stored parameters. So we can go down here and we press start, and you can see I have 5 of them already filled up. The rest are all empty. So I basically store the power on condition. So if I'm running some tests and I want to return it back to a power on condition, I don't have to power cycle the unit. I just go to the A register and retrieve it. So let's go back to the menu here. Now this is default. We can actually use this to check this transistor. So from here we just press start. And we're done. Now we got the first 4 traces are on here, but the other the other 6 traces are off the screen. So we can do some tweaking here to change that. So what we'll do is we'll go back into the menu, and one of the things we can do is reduce the number of steps. So let's change that to 3 steps. And now we can rerun it. So now we only have 3 steps visible. And now we can use the cursor keys. Bring that up, and we have 2 cursors we can use. This one here is the active one. And where the cursor is now, it always starts off in the center. So right now the collector voltage is 2.52 volts. Collector current is 2.6 milliamps. And we have an HFE of 260. Now we can also go to the other cursor and move it somewhere else. And move it down here to, well, say 1.76 volts. We have just 5.04 milliamps of current, and the HFE at that level is 252. So very very handy to have those cursors. Now, if we want to see all 10 traces, or all 10 steps, I should say, we can go back and select 10 steps. And what we can do, there's a couple of things we can do here. We can either change the step size, the amount of current that's applied to the base, or we can increase the current going to the collector. But what we'll do instead is that we'll bring the step size down to 5 microamps. And let's try this again and see what happens. Okay, we still got a couple of traces that are still off the screen. So let's go back into the menu, and now let's reduce the step size to 2 microamps and rerun the test again. And yeah, they're all there, but we need to spread them out a little bit more. So what we can do now is that we can reduce the collector current. So let's reduce that down to 5 milliamps and rerun the test. And there we go. That's something a little bit better. So yeah. Anyway, that's some of the things you can do just by mucking around with the settings. Okay, let's try something else here. Let's go back into the menu, and let's up the voltage. Let's say the collector voltage to 10 volts. We're going to still keep a collector current of 20 milliamps and a base current of 5 microamps. And so let's see what we got here. Okay, a little bit better. So let's go back into the menu again. Let's select a step, current step on the base to 10 microamps. And let's reduce the collector current down to 10 milliamps and see what happens. Yeah. Okay. But anyway, I think you guys get the idea. But there's a couple other tests we can do. One of them is doing a repeated acquisition and charting the results as the device heats up, which is kind of a cool function. So let me get that set up here and we'll go for that. Okay, for the first test, we're going to test this transistor and see how it changes over temperature. So what we're going to do is we're going to go into our menu here, and we're going to change from a single acquisition to continuous acquisition. We got the type set for NPN. We have our collector voltage set for 5 volts. The collector current set for 50 milliamps. We have our base current step size set, or step current set for 50 milliamps. We're only going to do 3 steps. We're still terminating the emitter into a 1/4 ohm load, and we're limiting the power to 100 milliwatts. So first thing I'll do is get my super cold, and we'll spray a little bit of that on that transistor and get it nice and chilly. Now we'll start the test. And as you can see, as the transistor is warming up and going back to ambient, the traces are slowly going back to normal. Yeah, looks like it's pretty much done, I guess. Still going a little bit, but we'll stop it right there. Yeah, that's a nice function to have right there. Even if you don't use the super cold, you turn the the amount of power that it uses to test the device, and then you can just kind of track how the device changes just simply under test. And yeah, that's pretty cool. All right, test number 2. We're going to check for transistor breakdown voltages. So we are going to go into the menu, and we're going to go down to retrieve menu. And those settings I have in register F. So we will go down to register F, load those values. Now, when we run this, since we're using a higher voltage, we're using 50 volts, we have to fold this down. Because if we don't and we run it, it'll prompt you to close the cover, and then it will continue with the test. So close that cover, and we will start the test. Test complete. So our breakdown voltage for this transistor here, we'll turn the cursor on, and where it is halfway through, we're at about 25 volts. So we'll use this cursor here. Right about there, about 30 some odd volts, 30, 40 volts. I think it's the transistor is rated for 40, but right there. So yeah, pretty cool. Now you can set this up to drive the device into destruction, but you know, I didn't want to destroy the transistor, so I limited the amount of power that's going to be delivered to the transistor to 500 milliwatts, because the transistor, at least these 2N222s, are designed to dissipate about 625 milliwatts or so continuously. So another nice feature. And so there you have it, the Tektronix 571 curve tracer. Handy instrument. So if you find one of these and it's in decent condition, I would say that you know, as long as it's working properly, you probably can't go wrong. It is a very handy instrument to have. Sure, you can you know, test components with these, you know, these component testers, but you know, for simply identifying components, well, it's fine for that. But boy, these things, the curve tracers, you can really start getting down into the nitty gritty, and get down to you know, matching output transistors if you'd like. So yeah, it's a very useful tool. But anyway, guys, I think that's it for now, and we'll catch you later on down the road. Thanks for watching.